Conditioning in bees. Bees can learn about the world around them in the same way discussed previously in the book. They appear to have short-term memory, and they also show paradoxical reward effects. They also have successive negative contrast, and this is when an animal gets upset when they are given a better award first and then given a worse reward after that. But the classic condition inhibition or feature negative has been very difficult to show, and this may be because no one has come up with the right experiment yet. There are similarities and differences in human versus animal learning. Category and causal learning in humans. Category learning is learning to classify items as belonging to one category or another, and we can learn to use features as well. Causal learning is learning about the causes of certain effects. For example, cues, which could be the causes, become associated with the outcomes or the effects. Humans show blocking effects and conditioned inhibition as well. The Rescorla-Wagner model is used widely to show the connections between units, or also called nodes. Shanks proposed connectionist models, and he found that nodes corresponding to the feature that were presented are activated, and same with the nodes corresponding to categories. This works similarly to the Rescorla-Wagner model. Therefore, extinction weakens or destroys the connection between the feature and the category, which is called catastrophic interference. But his model only scratches the surface of the connectionist modeling. Hidden units are additional units that come between input and output. Hidden units can solve the problem of negative patterning. These connectionist models have been largely developed in the area of human cognition. Some disconnections between conditioning and human category and causal learning. Findings in these two types of learning that are inconsistent with classical conditioning in animals. Shanks and Darby did a study with food and allergic reactions. It was hypothetical, in which they found that humans may do more than simply associate features with outcomes. For example, backward blocking is when AB positive occurs before A positive. It does occur in humans, and there are two approaches. The first is expand existing conditioning models, and to assume humans learn about cues and outcomes in a fundamentally different way. A probabilistic contrast model is when we can learn and remember something like the probability of an outcome given various cues. If the outcome is more probable when the cue is present, there is a positive contingency, and if the outcome is less probable when the cue is present, it is a negative contingency. Focal sets are the presence of A is a focal set within the contingency between B and the outcome is 0. This explains both forward and backward blocking. Van Heim and Wasserman suggested to think about backward blocking is that the subject is learning about the absent cue, B, when the other cue is being treated alone in a second phase, A positive. Causes, effects, and causal power. Causal relation goes beyond a simple connection. Causal power is transmitted from the cause to the effect. Waldman and Holyoake found that causes can compete, but effects do not. Several recent experiments challenged this, and they favor associative models, and many processes contribute to one effect.